All right, so we're solving exponential equations. An exponential equation is where the variable is in the exponent. Now we have done that already in when we did common bases here. So we are going to be not having common bases. And one of the things that is going to be useful in the future for this particular video, I'm going to switch things up a little to the way I normally do it. But you will be introduced to other methods where the ln of e is equal to 1 is going to help you. When we solved with common bases, it was nice because everything was of a power that we could figure out. Like 4 cubed was 64, so it'd be 2x plus 1, and 16 was 4 squared. Then we would drop the 4's and solve the equation. That's great and all, but what happens if you have 64 and 6? These do not have bases that we could legitimately find without using logarithms anyway. So, what do we do when we are trying to solve for an exponent in an equation and you cannot find common bases? You must use logs. It's the only way. That's actually why logs exist. They exist to be the inverse of exponents. Yep, that's why. Now this written here, these steps are one way to solve log equations. And you may have been introduced it. You will see it in the future in other videos and things like that. But I wanted to stay a little bit more consistent to what we've been doing. So instead of step 2 being log both sides, step 2 and step 3 are going to be do the log exponential switch. And that's what we just did yesterday. But in this case, we're going to be doing it the other way. So this is b to the e equals n being switched to log base b of n is equal to e. So we are switching it to logs, and that's going to help us. So if we have a log equation that we can't solve, we switch it to exponential and see if we can. And if we have an exponential that we can't solve, we switch it to logs. They're inverses of each other, just like square roots and squaring. So exciting. All right, we're going to solve each equation for the indicated variable to the nearest tenth. So I got to remember that. All right, so we isolate the base with the variable and the exponent. So this is the base with the variable and the exponent. It is isolated. Now we do the log switch. So it's log base 3 of 5 equals x. Look at that. X is solved for. We're basically done. We just plug this into our calculator, and it's 1.46497, blah, blah, blah. Goes on forever. That's an x. Rounded to the nearest tenth, it's 1.5 equals x. Nice. That's it. That's solving exponential equations. Okay, we're going to have to isolate a little. We're going to have to solve a little bit more, but that is the basic gist. So here we have the base is isolated. 8 to the x plus 3 is all by itself on this side of the equation. So then we solve. Log base 8 of 6 is equal to x plus 3. Nice. Now we solve this. Now there's two ways to solve this. You could put log base 8 of 6 into your calculator and then subtract 3. Or you could subtract 3 and then put it all in your calculator at the same time. It's up to you. Just be careful when you're doing these in your calculator. Do not put the minus 3 inside the parentheses. Okay? Only thing you have to be aware of, if you do put this in the calculator early, do not round. Okay? Until the end. Okay? If you round early, logs, you're going to be off by hundreds of thousands. Okay? So it's definitely not a good idea to round early. You want to round only at the very, very end. So that's why if you plug it all in at once, you don't have to worry. It just does it. And this one is negative 2.1383. Blah, blah. And it's negative 2.1. Cool. All right, let's just do a few more examples and see how this goes. Hopefully it goes okay. Isolate. 6 to the 2x is not by itself. We have a 3. Get rid of the 3. Okay, and now it's isolated. Now we solve. So in order to solve, we switch. So it's log base 6 of 103 equals 2x. Now the same deal here, we have an x. So you can put log base 6 of 103 in your calculator, then divide by 6. Oh, then divide by 2. I do not think I divided by 2 in my answer. Let me pause and get the correct answer. All right, so the answer is 1.2933, blah, 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 blah. Okay, so if you do want to put all these things down, you can write the whole thing, but you can just do dot, 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 and then round at the end. Okay, that's a completely acceptable thing, as long as you leave that in your calculator if you have more calculations to make. Alrighty, solve. 5 must be gotten rid of. Okay, that's e to the 2x equals 25 equals 10. I knew that. I am super good at this. So it's log base e, which we all know log base e is just ln. So log base e of 10 is equal to 2x. Then we divide by 2. Remember, ln is just a button in your calculator. ln of 10, make sure the parentheses are closed, or you hit enter, and then divide by 2 is equal to 1.15129, etc., or 1.2 is x. If I do make a mistake, please let me know, because I do that sometimes. Not often. I'm kidding, all the time. Isolate the power. So this is the power. It needs to be by itself. So I isolate it, I divide, and I just get 34 over 15. Again, at this point, if you figure out what the decimal is, you're welcome to write the decimal equivalent, but do not round. Okay? Do not round it. Okay, whatever weird number that is, weird decimal, just leave it in your calculator and use it the way it works. I don't tend to do that because I don't like to. So then this is, oh, I can't switch it around yet. This is fun. I haven't made a video in so long. Okay, so now we want to switch it around. So this is log base e, as we all know, is ln of 34 over 15 equals 0.05x. So divide by 0.05. Alrighty, and we get 16.3662, blah, blah, blah. So it's 16.4. If we did this and we rounded it too soon, this number would be way, way off, even though most of your work could possibly be correct. And I have zero confidence in myself right now for some reason. All right, 4 to the x plus 2. So this is the power part, and we're isolating it by adding the 2. Now, log base 4 of 14 is equal to x plus 2. So then I'm going to subtract my 2. Subtracting. Alrighty, plug that all in the calculator, and you get negative 0.0963, and negative 0.1 would be to the nearest tenth. A couple more, because it's just that much fun. Okay, just doing the logs and all that stuff. So this is only one way to approach these problems. There are about 6 or 7 different ways to solve these. And if you know a way and it's more comfortable to you, go crazy. Log base e is ln of 4 equals x. So remember, log base e of 4 equals x. Log base e is just our ln. So I'm just shortcutting that away, and all I have to do is type in ln of 4. And it's 1.386. Rounded out is 1.4. And then finally, we have this guy. These are just fun. They're just a good time. Just hang out with my friends. Sorry. I'm thinking of my imaginary friends and I hanging out. Anyway. You're not listening. It's okay. Alrighty. So that's that. We plug it in. Again, plug it all in at the same time. 0, 8. There we go. And so rounded would be negative 0.7. All right, again, this is one way. Other ways are perfectly fine. I just want you to be aware of this way, and other ways will be introduced to you in the future. Have a wonderful day. See you later.